A geometric sequence is a sequence that is either multiplying or dividing. As with arithmetic sequences, geometric sequences also have two formulas, the recursive formula and the explicit formula. This is the recursive formula. It has two parts, f1 equals a and fn equals fn minus 1 times r, with a being the first term and r being what we call the common ratio. These are the only two terms that change. You may have noticed that in the beginning of the video, I mentioned that a geometric sequence is a sequence that is either multiplying or dividing. You may have also noticed that in our recursive formula, there is a spot for a number that we are multiplying. In order to show that we are dividing in our sequence, usually we will multiply by a fraction. This fraction will be in the form 1 over x, with x being the number that we are dividing by. For example, if your sequence divides by 2 between each number, then you will multiply by 1 over 2. And if your sequence divides by 3, then you will multiply by 1 over 3. Now we will move on to the explicit formula. The explicit formula for a geometric sequence is fn equals a times r to the power of n minus 1. Let's use an example sequence and plug the numbers into our formulas. But first, to do this, we will need to know the value of r, or the common ratio. To do this, you will need to divide the second term by the first term, and then divide the third term by the second term. In this example, it would be 8 divided by 4 and 16 divided by 8. You should get the same number both times. This means that your sequence is indeed geometric. Now we know that 2 is our common ratio. If your sequence alternates between positive and negative numbers, this means that you are dealing with a negative r value. Now we'll plug the numbers into our formulas. We'll start with the recursive formula. Because 4 is our first term, that means that it is our a, which means that the first part of our recursive formula will be f1 equals 4. And we already determined that our common ratio, or r, is 2. So that means the second part of our recursive formula will be fn equals fn minus 1 times 2. And for our explicit formula, we'll use the same numbers, but put them in different places, according to where they should go in our explicit formula. We will end up with fn equals 4 times 2 to the power of n minus 1. Now, we will find a later term in the sequence. We already have our explicit formula with the numbers plugged in. The explicit formula is the formula that we usually use to find later terms in the sequence. For instance, if we wanted to find the 12th term in the sequence, we would plug 12 in for n, and then we would end up with f times 12 equals 4 times 2 to the power of 12 minus 1. Now we simplify, and we get f times 12 equals 4 times 2 to the 11th power. Most teachers will let you leave it here. However, if you were to do the rest of the math, for this sequence, you would end up with the following number. F times 12 equals 8,192.